Now, don't get all upset, but the moon is shrinking and getting wrinkled, pretty much like a grape turning into a raisin. That happens because our natural satellite has been retaining its inner heat for over 4 billion years, but its core is gradually cooling down and becoming more dense, like me. Unlike a grape's flexible skin, the moon's surface is pretty brittle. This brittleness causes faults to form where different sections of the crust push up against each other, leading to what scientists call moonquakes. So far, our satellite has shrunk by around 150 feet in circumference. It's such a tiny change that it won't affect the look of eclipses or the phases of the moon. Even tidal cycles won't be affected since the moon's mass hasn't really changed. The shrinking process won't directly affect us down here, but that doesn't mean that all humans are safe. Moonquakes, caused by the shrinking process, have been a concern for years. During the famous Apollo missions, NASA astronauts left seismometers at different points on the moon. Those are devices capable of identifying seismic activity on the lunar surface with exceptional precision. The equipment was operational for several years, and it managed to capture over 12,000 moonquakes, ranging in magnitudes from 2 to 5. Up until 1977, the team was able to identify 4 distinct types of quakes. Some tremors, like those caused by meteorite impacts, were relatively easy to identify. But the cause of the so-called shallow moonquakes remains a mystery to scientists, and that can be an obstacle to future missions on lunar soil. As the name suggests, shallow moonquakes occur relatively close to the surface, typically between 30 to 135 miles beneath the surface. Recent research suggests that these tremors are triggered by the compression of the moon's surface, leading to the formation of thrust faults, where one surface layer is pushed up over another. This study also discovered where the epicenters of the strongest ones were. It all started in the South Pole region, precisely where we want to settle down. Interest in the lunar South Pole peaked in 2023, when India's Chandrayaan mission successfully landed and deployed a rover to explore the area. NASA also has plans for the same spot. And their ambitious goal is to take astronauts there for the very first time. The Artemis III mission, scheduled for 2026, currently has 13 potential landing spots at the South Pole, represented by the blue squares here. One of the options is situated within a geological feature called the Gerlach Rim 2, which is a strategic area for exploration. It might have ice, because parts of it are completely in the dark, but it's close enough to areas that do have sunlight, which is crucial as a source of power. Now, take a look at the pink dots on that same map. They represent possible epicenters of the strongest moonquakes recorded by the Apollo missions. That means that thrust faults in the area could be relatively young and potentially active, representing a real danger to the Artemis III crew. These astronauts will journey to lunar orbit over the course of 30 days, and 2 crew members will descend to the surface, spending about a week at the South Pole. Their moonwalk will be particularly challenging, given the extreme temperatures of these permanently shadowed regions. The presence of moonquakes and possible landslides only adds more danger to this mission, as this phenomenon is far more frightening than earthquakes. The strongest moonquake ever recorded had a magnitude of 5.7. You might think that's not a big deal, considering that countries like Chile, Colombia, and Papua New Guinea experienced earthquakes of similar magnitude in 2023 without significant damage. But the gravitational pull on the moon is relatively weaker than on Earth, so what feels like a gentle tremor on our planet might be a real ground-shaking event up there. This happens because you're not as firmly connected to the surface of the moon as you are on Earth, meaning that seismic waves can cause the surface to move more freely. There's also a huge difference in duration. Earthquakes typically last between 10 and 30 seconds, with some lasting up to 2 minutes. A moonquake can persist much longer than that. Our satellite is essentially a solid, rigid, and dry sphere. So, when a tremor shakes the moon's surface, it resonates powerfully without any natural means of dissipation. Moonquakes can last for a good 10 minutes or even longer, with little tremors sticking around for hours afterwards. Now, these new findings about shallow moonquakes won't actually change the potential landing sites for Artemis III, and they won't affect the duration of the mission either. That's because accurately estimating how often a specific region experiences these tremors is tricky and unpredictable. What scientists do know is that these shallow quakes aren't very common and pose a low risk to short-term missions on the lunar surface. But that situation changes completely if we consider long-term habitation on the moon, and that could happen sooner than we expect. The Artemis III mission represents an important first step towards space colonization. China is also making the first moves to establish a permanent lunar base at the South Pole by 2040. Their strategy involves utilizing 3D printing and brick production from lunar soil for constructing the moon base. That definitely sounds fascinating, but putting together a setup like that comes with a bunch of challenges, including dealing with intense cosmic radiation, the lack of water, and of course, long-lasting moonquakes. Over billions of years, the surface of the moon has been hit by asteroids and comets, causing bits and pieces to constantly break off from the impacts. Because of this, all the surface material is pretty loosely packed, so when there are quakes, slopes in the same area can become susceptible to landslides or new faults opening up. Future settlements located too close to these unstable slopes could put everyone living inside these lunar bases at risk. Moon dust adds another layer of complexity because, without erosion or water to smooth it out, it can harden to the point of being as tough as glass. If we really want to understand how dangerous moonquakes might be for people living and working on the moon in the future, space agencies still need to map out and get new seismic data, and not just from the South Pole, but from the entire satellite. In 2025, the Far-Side Seismic Suite mission, or FSS, plans to deploy two of the most high-precision seismometers ever built to the Schrödinger crater, which is located on the dark side of the moon. Finding out what's happening on the ground there is crucial for understanding the complex lunar structure and its internal dynamics. Scientists are still trying to figure out whether the lack of recorded seismic activity on the far side of the moon is due to current instruments not being capable of detecting it, or if it's due to some kind of interference from melted material in the mantle. Once they have this answer, it will be easier to fully understand the phenomenon of shallow moonquakes and assess their implications for future neighborhoods on our natural satellite. Now, you may have heard that Earth is also shrinking, but it's a different process. Basically, the moon is getting smaller mainly because its core is cooling down naturally. The Earth's core is cooling too, but our planet got its crust with tectonic plates, unlike the moon, which only has one plate. So the energy from Earth's core shifts those plates around or comes through volcanic eruptions. Earth is actually losing mass overall due to atmospheric loss. Our planet loses about 100 million pounds of mass per year, mostly from a leaky atmosphere. Earth's gravity isn't strong enough to retain the lightest particles, like hydrogen and helium, which escape into space. But don't worry, these numbers aren't cause for alarm, considering that our planet's atmosphere weighs about 5 quadrillion tons, a number I can't even imagine. So, in other words, it would take many, many, many times the current age of the universe for it to completely evaporate. Well, that makes me breathe easier. How about you? So, Mars has several faces. No, really. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted something interesting. A big structure that looked like a human face. It was in the region called Cydonia. It soon became very popular. A bit later, we also discovered the so-called crown face in Libya Montes. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, like something from an ancient Egyptian tomb. A lot of people hyped that story up. The image was shared widely on social media, making the crack look bigger than it really is. Some people think that it's hinting at extraterrestrial life. But after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The crack formed naturally over time, maybe from wind erosion or Mars quakes. Mars is a gold mine of mysterious structures. Recently, we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or ice. These lava coils are shedding light on that mystery. Now, thanks to high-resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. What's fascinating is these lava coils are like the ones we see on Earth, like those formed by Hawaiian lava flows. These spirals are so well preserved that they were easily overlooked before. They range from 16 to almost 100 feet wide and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle. We still don't know much about those. But Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern. It's about 9,000 miles long, making it larger than the diameter of Earth. It's thought to be a jet stream made of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 80s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from blue to golden over time. There are different ideas about why Saturn has this thing. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow-spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with the bizarre moons. One of them is called Lapidus. This moon has a weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. Where's my nutcracker? This ridge is incredibly tall by our standards, around 8 up to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the moon's surface and is considered the third largest mountain range in the entire solar system. Now, we don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons. There's one idea, though. The ridge might be the remnants of a dead moon. Let's say billions of years ago, a colossal impact shattered chunks of material off Lapidus. These pieces circled around the moon, forming a mini-moon or sub-satellite. And over time, the gravitational pull of Lapidus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Lapidus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because, luckily, Lapidus was quite far away from it. If Lapidus was closer to Saturn, its moon might have been pulled away. But we do need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on in its methane seas. Scientists have spotted these strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem. In water, molecules stick together, which is why stuff can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet, these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this holy ice come loose from the edge of the lake, they can float on Titan's seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by wind. We need more research to know for sure. Moons like to be weird. Just look at our own one. In 1971, we found a patch with missing soil on our moon, and it looks like a blue lake. They call this mysterious spot Ina. We first spotted it during the Apollo 15 mission in 1971. Later, the Apollo 17 mission took clearer pictures of it. This spot, shaped like a bluish D letter, is one of the weirdest things on the moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Ina. Ina is unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. It's similar to the surface age of the volcanic field that surrounds Ina. Now, our moon has its own face, just like those on Mars. There's an area near the moon's south pole that looks like a face, but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. Well, that's because our brains are wired to recognize faces, even when there aren't any. It's a phenomenon called pareidolia. Our brains try to make sense of shapes, so when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes like Mickey Mouse. So don't worry, it's not extraterrestrial life. It's our brains that play tricks on us, making us see familiar shapes like faces even where they don't really exist.
Soon we might start constructing loads of stuff on the moon. All because India's moon mission has recently detected sulfur near the moon's south pole. This chemical element can come in extremely handy for creating infrastructure on our satellite. It's the first time this chemical element has been discovered on Earth's natural satellite. This sought-after element is mostly found near Earth's volcanoes. Its appearance on the moon speaks volumes about the satellite's volcanic history and its past atmospheric conditions. The mission's rover detected this chemical element less than a week after touching down around 70 degrees from the moon's south pole on the 23rd of August, 2023. This historic landing on the lunar surface made India the fourth country to safely land a mission on the moon. It's also the first spacecraft to touch down so close to the south pole of our satellite. It's an area of strategic importance because it's believed to be home to deposits of water ice. If it turns out to be true, future missions might be able to harvest it and turn this water ice into drinking water or even rocket fuel. For 2 weeks, the lander carried out the data collection, mainly focused on the analysis of the moon's soil and its extremely thin atmosphere. Meanwhile, the solar-powered Pragyan rover started its quest to find frozen water on the moon. As for the lander, it demonstrated another amazing feat on the 3rd of September. The spacecraft fired up its engines and lifted itself for about 16 inches into the air. Then it made a tiny hop to land 12 to 16 inches away from its original position. It's kinda a big deal. Being able to get a lander back off the surface of the moon is essentially for future missions, showing that they can safely return soil samples or even astronauts back home after a lunar mission. In September, the Indian spacecraft was put into sleeping mode. The 14-day-long lunar night was approaching, and the spacecraft wasn't designed to collect scientific data during this period of time. So far, we've learned about a few major findings of the mission. One is related to measuring the temperature of the moon's topsoil at different depths. Intriguingly, the surface of the satellite in that region turned out to be hotter than expected. It was believed that the temperature could be between 68 and 86 degrees Fahrenheit on the surface, but it was around 158 degrees Fahrenheit, way hotter than it should be. The other discovery indicates the presence of several chemical elements, including oxygen. Besides, the data received from the spacecraft confirms the presence of aluminum, calcium, iron, titanium, silicon, and other chemical elements on the lunar surface close to the South Pole. The rover also used special instruments designed to measure quakes and rumbles beneath the lunar surface to detect some seismic activity. It brings us back to the sulfur detected thanks to the rover's spectroscope. Scientists are currently working on figuring out whether this element formed on the surface in a natural way or whether it's the result of volcanic activity or a meteor strike. Another astonishing thing found on the Moon is a rock, and it may be the oldest known Earth rock. A 0.7-inch wide chip included in a large rock collection brought to our planet by Apollo astronauts might actually be a 4-billion-year-old fragment of Earth. This finding could help us paint a better picture of the intense pounding early Earth got at the dawn of its life. It could go like this. Soon after the rock formed, an asteroid impact might have blasted it from Earth. At that time, our planet's satellite was 3 times closer to Earth than it is today. The collision was so powerful that this chunk of terrestrial rock found its way to the Moon. Later, this fragment got engulfed in a lunar breccia, a motley kind of rock. Eventually, the rock was brought back home to Earth by Apollo 14 astronauts. Even though scientists had found meteorites coming from Mars and the Moon before, it was the first time a rock from the Moon turned out to be a terrestrial meteorite. They also found out that the rock had formed in a water-rich environment at temperatures and pressures corresponding to those at around 12 miles beneath the surface of our planet. In 2019, China's Chang'e 4 mission made history by landing on the far side of the Moon. The mission's rover helped researchers visualize structures hidden deep below the surface of the satellite, revealing billions of years of lunar history. The Yutu-2 rover made this discovery with the help of its lunar penetrating radar. It imaged deep into the Moon's surface and listened to echoes of sound bouncing back off structures hidden from view under the surface of the Moon. It turned out those structures were resting at depths of almost 1,000 feet. The research suggests that the first 130 feet under the surface are made up of layers of dust, soil, and rocks. The instruments also discovered a concealed crater that must have formed after a large object slammed into the Moon's surface. Long, long ago, ancient lava was likely to be flowing deep underground. Researchers believe that the broken rocks around the formation might be debris produced by the impact. They also found that the volcanic rock layers were thinner the closer they were to the surface. Such a thickness variation of lava flows might mean a decrease in the number and magnitude of eruptions over time. So, lunar volcanic activity gradually dwindled since the Moon's formation around 4.5 billion years ago. On the far side of the Moon, there is one of the largest and oldest impact craters in our solar system, the South Pole Aitken Basin. Unfortunately, from Earth, you can only see its outer rim, which looks like a huge chain of mountains. It's a ginormous 8-mile deep dent, stretching for more than 1,500 miles in diameter and covering 1/4 of the Moon's surface. Astronomers are sure that this crater appeared when an asteroid collided with the Moon around 4 billion years ago. And now, look at this gigantic chunk of metal the size of 4 states of Connecticut. As for its weight in pounds, it's enough to say that the number contains 18 zeros. This mysterious mass is hidden about 180 miles under the Moon's surface, somewhere in the middle of the South Pole Aitken Basin. It was discovered when GRAIL, which stands for NASA's Gravity Recovery and Interior Laboratory mission, gathered data about our natural satellite. When examining this information, scientists noticed that in one place on the Moon's surface, there was a weird change in gravity. After researching this phenomenon, they concluded that something mysterious was weighing down the basin floor there. So far, researchers haven't figured out the origin of the bizarre lump, but there are several theories. One of them claims that the finding is a chunk of dense oxide, which appeared when the moon was just taking its shape. At that time, the satellite was still covered with ancient oceans of magma, and the lump could be formed at the final stages of its cooling. However, most scientists support another theory, according to which the puzzling mass is part of the giant asteroid that once created the South Pole Aitken Basin. Since the thing is metallic, it's probably the iron-nickel core of the asteroid. There might be a labyrinth of lava tubes on the moon. Not so long ago, astronomers received the results of underground topography and discovered a massive cave under the surface of Earth's satellite. It could be the result of the lunar volcanic activity that happened more than 3 billion years ago. Streams of lava hardened, creating a thick, hard crust on the outside. But inside, it kept flowing, melting the rock and creating tunnels and caves. Numerous small pits in the moon's surface discovered by NASA seem to be the openings to such lava tubes. If this theory is confirmed, the underground tunnels might serve not only as a convenient location for human-crewed space missions, but also as much-needed water sources for astronauts.
August 23, 2023, a day when India's Chandrayaan-3 spacecraft made history by becoming the first to touch down on the lunar South Pole, a place we can't normally see from Earth. What makes this lunar hideaway so fascinating to scientists? Well, it turns out it's hiding something precious: lunar ice. This place is believed to be more abundant with this ice than what we found up north. And it's not hard to see why scientists are so buzzed up about it. It's a frozen water source, and it could become our key to building a permanent lunar home, or even fueling missions all the way to Mars. Scientists knew about this ice for over 2 decades, since the NASA spacecraft accidentally stumbled upon it during one of the missions. Then in 2018, NASA triumphantly declared that they're 100% sure about it. They said that the south pole of the moon is abundant with water. Now, picture this. Future lunar settlers could tap into this water supply. It could help us sustain life in the barren lunar landscape. Plus, by cleverly splitting the water into oxygen and hydrogen, we could receive both air and rocket fuel. All this will make moon missions more feasible and self-sustaining. It's also a great glimpse into the past. This ice, maybe as old as the moon itself, could unlock the moon's and Earth's deep mysteries. But it turns out that water isn't rare in space at all. There might be lots of planets out there where life could thrive. We know this because we started finding water vapor around stars, and this water is remarkably similar to the water in our own solar system. This discovery suggests that the water on Earth originally came from space. Water forms around stars in the cloud of extremely hot vapor. Then it turns into ice and sticks to tiny dust particles. These particles stick together over time and become bigger objects, like comets, planets, and other things. Some of these become comets and planets in our own solar system. And this is how water is being spread across the universe, and it may be how it got to our planet and the moon too. Scientists think that the lunar ice might have journeyed here eons ago. Maybe it hitched a ride on water-rich asteroids that smacked into the moon's surface. All this has big implications for us. The southern pole is an ideal canvas for humanity to establish a real moon base. Imagine brick domes connected by secret underground tunnels. They'll be bustling with people busily operating computers. Some others will be cruising the lunar landscape in their jeeps or on their way to mine precious resources. We have some pretty cool ideas on how to build this. First, you probably imagine hauling hefty and water-draining shelters all the way from Earth. But maybe there's a more effective way. Think about our history as a civilization. Every time we ventured to a new place, we surveyed the surroundings for available resources and used them to survive and thrive. This is how we spread across our own planet. So why shouldn't we spread across the moon the same way? Now, you might wonder what resources the moon might offer. We know about the ice, and it can be turned into water, but we can clearly see that our planet lacks lush greenery and edible food. Well, it might not be obvious, but the moon does have something to offer: mineral resources and sunlight. Unlike Earth, where the sun rises and sets, the lunar poles offer quite a beautiful sight. The sun gracefully orbits the horizon the entire day, which means it can provide an almost uninterrupted source of power. Imagine living in a world bathed in perpetual sunlight. I'm sure the solar panels will love it. Me? Not so much. Still, we could use not only the sun's light, but also its heat. Honestly, we should just use everything. If we're left with spare metal while producing oxygen, find a purpose for that metal too. We need to treat the environment responsibly, not only on Earth, but on the moon as well. Which is why scientists are learning how to turn the moon's most abundant resources, regolith, into sturdy bricks. They've been quite inventive in figuring out how to create moon bricks. Scientists want to use the sun's heat to melt lunar dust, layer by layer, essentially creating a 3D printer for moon dust. Engineers have also cooked up bricks using solar ovens and zapped lunar soil with microwaves. They become quite adept at it. So yeah, perhaps we're going to establish a little brick factory on the moon and build regolith houses. It's like Minecraft in real life. As soon as you find some cool new material, you gotta build a tiny house with it. If successful, these bricks could be used to construct entire buildings, potentially covering inflatable modules or giving new life to abandoned landers. So, will astronauts need to become skilled bricklayers? Well, they won't do everything themselves. We'd have to create a small automated system involving robots working collaboratively. Humans will, of course, oversee the construction site. Despite all this automation, scientists believe that living on the moon is going to be, well, call it cozy. The designs may involve stacked living quarters or multi-purpose areas. However, there would be some challenges too. On the moon, things get extreme. Imagine scorching temperatures that can go up to 212 degrees Fahrenheit during the day, and at night, they plunge down to a chilly minus 290 degrees. And it's not just the weather. The moon gets relentlessly exposed to solar radiation, cosmic rays, and micrometeorite impacts. All these things gradually wear down anything on its surface. Another big challenge is the lunar dust. On the moon, there's no air to breathe, and the dust there can cause problems. And this one isn't only regular dust. It's super clingy and can even make astronauts sneeze and have watery eyes, as if they're having a lunar hay fever. It can also damage equipment and spacesuits. It's not something you want to mess with. Scientists have found that the dust is made when meteors hit the moon, creating tiny particles and sharp glass shards. It's toxic, and its tiny particles can float around in low lunar gravity, making it hard to breathe. Unlike on Earth, the moon doesn't have wind or rain to clean it away. So now they're studying it to find out how to prevent this annoying problem from ruining their entire mission. There's more to this lunar haven than meets the eye. Scientists also want to delve into the mysteries of low-frequency electromagnetic waves there. These waves are whispers from the far reaches of the universe. These elusive signals have remained hidden from us for ages. We only caught some cacophony of radio and other background noise, but that's it. On the moon's dark side, however, we can finally record and study them. Studying these waves will help scientists to unlock the secrets of the universe's origins. It's not just about the Earth or the moon. We're talking about peering back to the very beginnings of our world. Our new lunar lab might help us to forever reshape our understanding of the cosmos. So, NASA has some big plans on the moon now. Their Artemis mission completed a successful return to Earth in December 2022 after nearly a month in space. It ventured far beyond the moon. This mission proved the capabilities of some of our recent technological developments that will help us explore Mars. The goal of Artemis is to establish a lasting presence on the Moon. They want to create a gateway, like a space station in orbit around the satellite, to help with the landings. Artemis II is set to carry astronauts to lunar orbit in 2024, and during Artemis III, which should take place in the mid-2020s, 2 astronauts will touch down near the Moon's south pole. It's quite possible that the lunar base will be built within the next couple of decades. So, stay tuned.
It's one small step for man, one giant leap for mankind.
Is one of the most famous quotes of all time. But was it really what Neil Armstrong uttered on July 20th, 1969, as he set foot on the Moon for the first time in human history? It looks like it both is and is not. Thousands of people back on Earth who were following the historical event heard the phrase without one small detail, the indefinite article, A.
It's one small step for man, step for man.
There's no such thing as small details when it comes to grammar, and the absence of A slightly changed the meaning of the whole sentence, since man and mankind became synonyms in that case. It basically meant, that's one small step for mankind, one giant leap for mankind. Neil Armstrong himself told the press after the Apollo 11 mission that there definitely was an A there, but people just didn't hear it. 30 years later, at the event's anniversary, Armstrong couldn't hear the article while listening to the recording of that famous transmission.
It's one small step for man.
He explained that he wasn't the most articulate person, and he left a lot of syllables out. So it could have been a suppressed sound, and the voice mic simply failed to pick it up. But he insisted that A had been intended, as without it, the statement wouldn't have made sense. In 2006, a computer programmer backed up Armstrong's words with some digital magic.
It's one small step for man.
He ran the audio through some software that singles out nerve impulses and saw it in the graphic form of sound waves. It became obvious that there was a 35 millisecond long bump of sound between 4 and man. It was too brief for other humans to hear, but Neil clearly did leave room for an A. Several years later, Ohio State University studied the speaking patterns of Central Ohioans, like the first man on the moon, and noticed that they often leave out words like for and A. In a BBC documentary, Armstrong's younger brother Dean mentioned that he had seen the quote written on a piece of paper months before the mission. Whether it really happened or not remains a mystery because he had never mentioned it before the documentary. Like with many famous quotes, people tried to find some symbolism behind Armstrong's words. One of his biographers suggested that the quote was inspired by the astronaut's love for J.R.R. Tolkien's books. There was a similar line in The Hobbit. Not a great leap for a man, but a leap in the dark. He found that connection because Armstrong had a Tolkien-themed email address in the 90s, and after retiring from NASA, moved with his family to a farm dubbed Rivendell. It was also the name of a valley and the home of Elrond, the half-human, half-elf from Lord of the Rings. Armstrong himself denied that connection since he hadn't read any of Tolkien's books before going on the Apollo 11 mission to the moon. Others believe the quote was based on the NASA memo. Going to the moon was no walk in the park, so it was important that the first person there pronounces some iconic words about it being a historic step forward for all mankind. Again, the astronaut denied having any memo. He later shared that it had just been the most logical and right thing to say. Armstrong literally had to go a long way to make that legendary step. He took his first airplane ride at the age of 6 in a Ford tri-motor plane with his father, and that's when he fell in love with aviation. He was an active Boy Scout and earned the highest possible rank, Eagle Scout. On his 16th birthday, he became a licensed student pilot before he got his driver's license. He then went on to study aeronautical engineering. His program involved 2 years of university studies at Purdue University, then leave for 2 years of flight training and 1 year of aviator service before returning to finish his final 2 years. While at Purdue, Armstrong joined a fraternity and wrote and directed a musical for the school varsity varieties. He was investing so much effort in his version of Snow White and the Seven Dwarfs that he got a C that term in psychology for engineers, a C in aircraft vibrations, and a D in electrical engineering. During his aviator service, Armstrong had to eject from the plane over the water. The winds were taking his parachute back to land. When he thought that was it, his friend from flight school in a service vehicle picked him up and saved his life. Armstrong came back to Purdue, completed his degree, got married for the first time, and became a civilian research pilot right after. The couple moved to California, and whenever he flew over their house, Neil would tip the wings for his wife and son on the ground to see it was him. He had over 1,100 flight hours testing various supersonic planes and the X-15 rocket plane. He wasn't able to apply when the U.S. Air Force was recruiting for the first Man in Space Soonest program in 1958 because they didn't accept civilian test pilots. In April 1962, NASA accepted applicants again for Project Gemini, and this time he was eligible. Neil handed in his application past the deadline, so it was only thanks to a flight simulator who had known him and slipped the application in the pile that he got into the space program. Back then, he wasn't considered NASA's #1 pilot and flew as a backup crew. In 1966, Armstrong became the first American civilian in space, and together with David Scott, pulled off the first manual space docking maneuver. And that's where things have gone wrong. After docking, a rocket thruster had a meltdown and the spacecraft started spinning uncontrollably. They had to separate from the Agena. Armstrong took back control of the Gemini spacecraft and they managed to perform an epic emergency splashdown in the Pacific Ocean. Then, it was time to choose who was going to become the first human on the moon. It had to be a civilian, and the decision makers at NASA chose Armstrong for that honor. Some people believed it was because he had a likable personality, quiet confidence, and was working hard on the way to the stars, literally. To prepare the astronauts for landing the lunar module and the reduced gravity they'd experience, NASA ordered practice vehicles to be built. In early May 1968, at just 98 feet above the ground, Armstrong's vehicle started rolling without control. He had to act quickly and eject to save himself. Later analysis proved that if he had done it just half a second later, that would have been his final moments. On July 16, 1969, Armstrong, along with other members of the mission, took off for the moon. NASA built the Saturn V, the most powerful rocket that had ever flown successfully, to take them there. It was as tall as a 36-story building. 4 days later, they reached their goal. After spending 21 hours and 36 minutes there, leaving their footprints which are still visible on the moon's surface, collecting surface samples, taking photos, and testing scientific instruments, and headed back to Earth. Armstrong didn't enjoy public attention that much, so he decided to take up a teaching career. He became famous worldwide, but he still had to work hard to defend his master's thesis at the University of Southern California. He then retired from NASA and moved back to Ohio with his family, where he would teach for the following 8 years. He didn't cut the connections with NASA altogether and worked with them on several commissions, helping the investigations into both the Apollo 13 malfunction and the tragic Challenger space shuttle incident. In 1985, Armstrong journeyed to the North Pole with a group of fellow explorers. It made perfect sense that he wanted to see it not only from space, but from the ground level. For his giant leap for mankind, Armstrong was awarded the Presidential Medal of Freedom, the Congressional Space Medal of Honor, and the Congressional Gold Medal.
How about playing golf? Not on Earth, but on the moon. Let's journey back to a time 50 years ago when one astronaut turned the lunar surface into the most unusual golf course ever. Any golfer will tell you how tricky it is to avoid sand traps, but picture Alan Shepard, a NASA astronaut dealing with an entire surface that feels like super fine powder. During the Apollo 14 mission, he took a break to showcase some spacey golf skills for everyone watching from Earth. After his first shot, he excitedly made another. For him, it seemed the ball went forever and ever. Let's dial back to reality for a moment. Thanks to the research by the United States Golf Association, or USGA, we've got some numbers. They found that Alan's first moon ball traveled 24 yards, and his second stretched for 40 yards. Now, how does that compare to the average golf shots back here? In regular gravity, one usually swings to about 216 yards. Just goes to show, while we've upgraded our golf game on Earth with tech and training, the moon's low-gravity playground is a different environment altogether. Now let's give Alan some props. Moon golf? Not as simple as you might think. His club wasn't one from your local sports store, it was a makeshift one. A moon sample collector with a club head stuck to it. Add to that the bulky spacesuit he had on. Imagine trying to swing wearing an outfit that's as stiff as cardboard. With all that gear, Alan could only muster a one-handed swing. Care to have a similar experience? Well, you might not be able to play golf on the moon anytime soon, but you can give it a shot underwater. Some say the conditions are similar. Here's where it gets even more interesting. The USGA didn't just take Alan's word on where the balls landed. They wanted to investigate. For starters, they used ultra-clear footage of the Apollo 14 mission. They also used some sharp images from NASA's special moon camera, launched in 2009. Using this imagery, they mapped out the journey of those two golf balls. Alan loved his unique golf club so much, he wanted to bring it back home. No big deal, right? Well, you see, in those days, astronauts would leave behind unnecessary items to make space for moon rocks. But not this club. So during the 70s, this interstellar golf club found a new home at the USGA Museum in New Jersey. Unlike regular golf clubs, this one had a twist. It was crafted from aluminum and Teflon. It was built to fold and fit snugly within the tight spaces of the lunar lander. How did this whole moon golf idea even pop up? Well, in 1970, golf legend Bob Hope paid a visit to NASA. Inspired by Hope's love for golf, an idea came into Shepard's head: moon golf. To turn his dream into reality, he collaborated with a golf professional and NASA's tech specialists. Together, they crafted a club that met NASA's strict safety norms. But hey, Alan didn't want this to be just a surprise stunt. Remember, traveling to the moon required very strict protocols. They couldn't just randomly have a picnic up there, you know? So, Alan made sure NASA officials agreed with this impromptu game of golf. They were initially skeptical, but eventually gave the green light after Alan passionately laid out his plan. He also promised he'd start playing if everything went smoothly on the mission. Determined to make it perfect, Alan prepped like a champ. The story goes that he'd put on his hefty spacesuit and sneak off to secret spots so he could practice. Decades later, he'd still be reflecting on his lunar escapade. He was the only golfer to ever swing on the moon. It's not just golf balls that astronauts left behind on their trips. There were actually a lot of objects left on the moon between 1969 and 1972, the year of the last moon landing. Each time you gaze up at the moon, remember that there's a cute family photo up there, some huge science gadgets, a small statue, a bunch of, well, human waste bags, and yes, some American flags. Years have passed by, and yes, technically those items are still hanging out there, though they've probably seen better days because of the harsh conditions on the moon. Some items had a special place in the astronauts' hearts and were meant to stay on the moon. But hey, leaving some stuff behind also meant they could bring back moon samples. You know the feeling. It's like when you need to make room in your suitcase for souvenirs when you're finishing a vacation. Does NASA have a complete list of things they left on the moon? Well, not really. In fact, one team tried to create a record of some of the items and reached an amazing list of 106 left there from the Apollo 11 mission alone. And that's not counting Neil Armstrong and Buzz Aldrin's famous footprints. The largest items at each landing site were mostly the sciencey stuff, like pieces of their lunar module and experiments to study the moon in depth. Then there were some beautiful tokens, like Apollo 11's plaque and a special disc with messages from leaders around the world. Some say the astronauts also took medals to remember some heroic cosmonauts, and they even left a gold olive branch, an age-old symbol of peace. Now, later moon missions had a little more fun, like Alan Shepard did with his golf game. But the award for the most heartwarming moment goes to Charlie Duke. During the Apollo 16 mission, he left a picture of his family up there. It's like he wanted them to be a part of the adventure. Although, a heads up, those photos probably didn't age well because of the moon's high exposure to the sun's radiation. There might just be an art museum up there on our satellite too. Let me explain. There's this tiny little art piece called the Moon Museum. It's a ceramic chip about the size of your nail, and it was crafted by an artist named Forrest Myers. This tiny object showcases miniature artworks from 6 talented people. Among them are even the famous Andy Warhol, the same artist known for his iconic soup cans and celebrity portraits. Forrest Myers said he wanted his mini museum to be on the moon, but there was a problem. NASA officials weren't exactly on board with the idea. However, Myers shared with the press that he handed over this art chip to an engineer working on the Apollo 12 mission. According to Myers, this engineer secretly tucked the Moon Museum onto a leg of the lunar lander. In case you haven't figured it out yet, these lunar landers don't come back to Earth after their mission. Take this with a grain of salt though, as NASA has never confirmed this story. You might wonder, why did they leave all these things? Sometimes it was about making a statement. Other times, it was purely practical. At one point, it was mentioned that during the Apollo 11 mission, for example, a decision needed to be made. The astronauts had to quickly figure out what was essential for their trip back home. They ended up creating a cleanup spot, tossing away things they didn't need anymore. Leaving things behind on the moon isn't that different from how we leave things behind on Earth. Just like archaeologists study our ancient leftovers to learn about our ancestors. The stuff on the moon gives us insights about those incredible lunar missions. Some things they left had done their job, like the pole for the flag or the camera they used to broadcast those steps on the moon. Even the tools astronauts used to collect samples were left because they had more precious cargo to bring back. Moon rocks. When it comes to the current state of all these items, scientists are not entirely sure. We do know that NASA's Moon Observer has spotted some of their shadows. They're still up there. The official gear was built to resist, so it might behave a bit better. But those personal items? They've probably seen better days.
NASA has some incredible plans for the moon. For example, their next ambitious lunar program, Artemis II. They've set their sights on landing astronauts, including the first woman and the next man, on the moon by 2024. Artemis is all about building a sustainable presence on the moon. They're planning to establish a lunar gateway, a sort of space station in lunar orbit, which will serve as a jumping-off point for lunar landings. And let's not forget about the cool lunar landers. Scientists are developing the mighty Space Launch System rocket, which will launch the Orion spacecraft carrying astronauts towards the moon. Then there's the Human Landing System, a snazzy lunar lander that will gently touch down on the moon's surface, allowing astronauts to explore and conduct amazing scientific experiments. And NASA isn't going alone this time. They're teaming up with international partners, like the European Space Agency, to make this lunar dream a reality. But all these wonderful dreams might be ruined by something that seems super small and insignificant at first. Picture this: no atmosphere, no air to breathe, and suddenly, a mysterious haze and radiant beams of light appear at sunrise and sunset. It's as if the moon is putting on a celestial show. But there is a twist to this beauty. During the Apollo 17 mission in 1972, This beautiful sight made one of the NASA astronauts, Harrison Schmitt, sneeze and made his eyes water. He called it lunar hay fever. This mysterious fever affected all 12 moonwalkers. From sneezing fits to stuffy noses, those astronauts experienced symptoms as if they caught a cold. It took days for the reactions to fade away. This event led to a discovery about lunar dust and its darker side. When scientists found out about these rays, they rolled up their sleeves and delved into their origins. And here's what they discovered. Those radiant bands of light were actually caused by sunlight sneaking through layers of teeny tiny lunar dust. The dust was composed of small particles and sharp glass shards and was lurking everywhere. And it turned out that this lunar dust was a sneaky villain. It brought a whole host of problems. Astronauts who found themselves with impaired vision were just the beginning. The troublemaker went even further, damaging precious machinery and causing electronic malfunctions. It even had the audacity to corrode components and smelled like burnt gunpowder inside the spacecraft. Yikes. It clings to everything, coating surfaces like a mischievous blanket. It can clog up equipment, get into delicate machinery, and even mess with astronauts' spacesuits. In 1972, things got really hairy again. The Apollo 17 astronauts faced a nightmare. After just 22 hours of gallivanting on the lunar surface, their spacesuits suffered irreparable damage. Yes, you heard that right. Irreparable. The dust diminished astronauts' mobility, making it harder for them to move around and perform their moonwalks with grace. And no matter how hard they tried to clean it off, it clung on for dear life, leaving the spacesuits in a sorry state. So, as you can see, it poses some serious challenges for future moon missions. But our intrepid scientists aren't giving up. To solve this problem, they have to understand how lunar dust forms and why it's so darn clingy. They found out that it all begins with meteorite impacts. When these space rocks crash into the moon, they generate a fine dust that fills the air. Sometimes these impacts even cause minerals to melt, forming sharp glass shards that mix with the dust. Talk about a moon makeover. The dust is also filled with silicate, a material commonly found on volcanic planets. Silicate inhalation can cause serious lung problems for Earth's miners, so you can imagine the trouble it can cause on the moon. A recent study found that even a scoop of replica moon dust was toxic enough to destroy up to 90% of lung and brain cells exposed to it. But it gets worse. The low gravity on the moon allows those tiny particles to float around for much longer, penetrating deeper into the lungs. Imagine breathing particles 50 times smaller than a human hair for months. That's a recipe for trouble. And you see, on the moon's surface, things are a bit different than here. There are no rainstorms or strong gusts of wind to blow this dust away. There is also no atmosphere to protect the surface. So without the natural forces of wind and water erosion like we have on Earth, these dry particles stick around persistently. And to make matters more electrifying, the moon is constantly showered by radiation from the sun. This exposure gives the dust an electric charge. The solar winds create positively and negatively charged particles. The particles then buzz around, repelling each other and giving rise to those radiant bands of light that the Apollo 8 astronauts witnessed. It's like a disco party on the moon. ESA, the European Space Agency, has gathered a team of experts to study the lunar dust. They're working with simulated moon dust mined from a volcanic region in Germany to understand its behavior and effects. Engineers also need to find a way to protect future astronauts and equipment. Engineers in NASA want to create spacesuits that can survive not 1, not 10, but a whopping 100 extravehicular activities on the lunar surface. That's like spending 800 hours out there, exploring and having a blast. Besides that, NASA initiated the Breakthrough, Innovative, and Game-Changing Idea Challenge in 2021. It was open to clever university students from all over the world. These young minds put their thinking caps on and unleashed a wave of innovative solutions. For example, they proposed using special fibers that conduct electricity, inspired by fluffy chinchilla hair. Just like how chinchillas stay dust-free, these fibers would help keep the lunar dust at bay. A furry friend lending a helping paw, isn't that adorable? Another bright idea involved an electrically charged brush activated by UV radiation. It's like a magical wand that zaps away the dust with a flick. Abracadabra, lunar dust be gone. And let's not forget the fabric inspired by clever insects. These insects have pollen-collecting structures that repel unwanted dust. So our ingenious students thought, why not mimic that? They designed a fabric with similar properties, creating a shield against the sneaky lunar particles. What's remarkable about these ideas is that they all use the power of charge to fight the dust. They cleverly repel it from the spacesuits, keeping them clean and protected. And even though all these ideas sound pretty great, scientists in NASA unleashed another, even better solution: carbon nanotubes. It's a great way to revolutionize spacesuit fabric. What makes these carbon nanotubes so special? Well, they possess some amazing superpowers. First off, they're superconductive, meaning they can carry electricity like nobody's business. It's like having a lightning bolt trapped inside a microscopic tube. Not only that, but these carbon nanotubes are tougher than the toughest meteors. They have the strength to withstand the harsh lunar environment, where even a speck of dust can cause trouble. Imagine having a suit made of a material that's stronger than Superman's cape. So, NASA's scientists decided to weave these extraordinary carbon nanotubes into the spacesuit fabric. The electrodes were carefully integrated into the outer layer of the fabric, making it a force to be reckoned with. But how do they banish the lunar dust? Well, here comes electrifying science again. When activated by a special alternating current, the electrodes create powerful electric fields. These fields work like magnets, repelling both charged and uncharged dust particles away from the spacesuit. Picture this like a dance party, where the dust particles are the uninvited guests, and the electric fields are the bouncers, swiftly escorting them out. Thanks to this technology, lunar dust doesn't stand a chance against our astronauts. Also on the bright side, the lunar soil can be used to make bricks for shelters. It can also help extract oxygen for astronauts to survive on the moon for long periods of time. When life gives you lemons, make a lemonade, right? So, let's cheer on our NASA Dream Team as they embark on this epic lunar quest. Let's hope that they succeed in their findings, and the next moon mission won't be a big problem. Stay tuned.
Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. What caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth, in its early stages, and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the Moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the Moon would just disappear right away. They believed the Moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the Moon in special areas called permanently shadowed regions. These are spots on the Moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the Moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the Moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the Moon's poles. They still weren't certain, so they kept digging and, after a while, found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the Moon today, which means water probably was present on the Moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our Moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the Moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the Moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the Moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days. or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too?
Never forget that it's an extremely powerful and massive star, with a surface temperature of about 10,000 degrees Fahrenheit. If it wasn't for our ozone layer, we would all get burned instantly. The distance between the Earth and the Sun is about 93 million miles. Scientists took this distance and turned it into a unit of measurement, 1 astronomical unit, or AU. The closest distance that the Earth could approach the Sun without being completely destroyed is about 0.9 AU. At the same time, if we move too far, further than about 1.2 AU, our planet will turn into a snowball. So we got pretty lucky with our location. Meanwhile, the distance between Earth and the Moon is about 0.002 AU, or 240,000 miles. It's super close to us. Now that we know how important these two are, and how much their position affects our world, let's try to swap them. Surely nothing bad will come of it. First, let's imagine for a moment that the Sun was in the Moon's place. You probably already know what will happen to us. The intense heat and radiation from the Sun would be like the world's worst sauna, with the temperature on Earth rising rapidly. Any living thing on Earth would leave behind nothing but a pile of ashes. But the destruction wouldn't stop there. The atmosphere and oceans would be stripped away by the solar wind, leaving the planet exposed and vulnerable to the radiation and particles coming from the Sun. It would be like a giant space hairdryer on full blast, with Earth's atmosphere and oceans being blown away instantly. Forget about melting ice caps. The entire planet would be one big puddle. But that was a scientifically accurate answer. Boo, boring. Now, what if we could somehow survive this catastrophe? Like, what if we had some super advanced technology to protect us from being fried to a crisp? First up, even if our planet somehow survived, things would still get pretty toasty, since the Sun would still emit way more heat and energy than the Moon. Also, unlike the moon, which goes through periods of darkness during its lunar night, the sun has a constant energy source through nuclear fusion. So at least we wouldn't have to worry about freezing every night. We'd just be sweating buckets in our sleep. Of course, all this extra heat would have some serious effects on our ecosystems. Plants and animals would have to adapt to survive. And we might see some major changes in the way life on Earth operates. Imagine the confusion of nocturnal animals. Without the moon, they would have no idea how to navigate or hunt. So, what would we do in this new, super hot world? Well, maybe we could build some seriously high-tech greenhouses to trap all this heat. Or we could use some giant mirrors or other reflective surfaces to manipulate the amount of sunlight that Earth receives. Next, we have the sun's gravity. Remember how we said that the moon's gravitational pull is just right for stabilizing Earth's orbit? So, if we replace it with an entire star, things would get pretty wacky. We're talking about extreme changes in seasons, climate, and all sorts of weather-related shenanigans. Your everyday life would look like it's trying to do the cha-cha slide during an earthquake. The Earth's rotation would also speed up drastically. This means shorter days, longer nights, and lots of confusion with working hours and birthdays. So, is there any way to fix this? Well, hypothetically, we could use some massive spacecraft or other technologies to artificially adjust Earth's orbit and rotation. For example, we could launch rockets or space tugs that would slowly push our planet into a new orbit that's more stable and consistent. And that's not all. All this gravity play would also mean new tidal waves of epic proportions. We're talking waves so high that surfers would need oxygen tanks just to catch a ride. Imagine trying to sail a boat through a hurricane while riding a bucking bronco. Yeah, yeehaw! The moon also mixes up nutrients in the ocean and helps support marine life. So if we swap the sun for the moon, those nutrient-rich waters would be a thing of the past. The ocean would become a stagnant, lifeless soup, with nothing but algae and plankton to keep us company. We'd have to resort to eating seaweed sandwiches and drinking desalinated water just to survive. And let's be real, nobody wants to live in a world without sushi. So what do? Well, we could try to somehow artificially create tides or mimic the moon's gravitational pull on the ocean. Like using pumps or other mechanisms to move large volumes of water around in a way that creates a similar tidal effect. Or we could try to help marine life to adapt to the new, less nutrient-rich ocean. Maybe developing fish farming or aquaculture. Finally, don't forget about radiation. The sun is basically a radiation factory. It could seriously mess with our health and electronic devices. You think your phone is fragile now? Imagine what would happen with it under a giant solar flare. So we'd need some seriously advanced shielding technology to protect us. We're talking materials that can withstand temperatures hotter than a jalapeño's backside, and magnetic fields powerful enough to deflect charged particles. Oh, and tons of sunscreen. In summary, if we replace the moon with the sun and somehow manage to avoid catastrophic consequences, it would be a completely different world than what we know. But it wouldn't just be the Earth that would feel these effects. So what would happen to the rest of our solar system? For starters, if the sun, with its crazy gravitational pull, took the moon's place, it would start seriously messing with the other planets' orbits. They might be sent careening off in random directions, like bumper cars. The planets would also have some taste of the sun's fiery personality. They would have to deal with all the radiation and charged particles. Lastly, the sun's magnetic field is incredibly strong, and if it took the moon's place, the other planets would be forced to dance to its tune. This could cause electrical storms, auroras, and other crazy electrical effects everywhere. And what would happen to the moon itself? Unfortunately, its reign in the center of our solar system won't last too long. Most likely, it will either start orbiting the sun and be eaten by it, or simply fly away like a free birdie. So there you have it, a cosmic prank gone horribly wrong. What can we say? Let's just be thankful that such a scenario isn't physically possible, and instead enjoy the beautiful moon and the life-giving sun from a safe and comfortable distance.